if u equals to x square y square upon x square plus y square log y upon x, and v equals to cos inverse xy upon x square plus y square, and also the question is saying that z is equals to u plus b, then we need to find the value of this expression. If you remember, students, we are having two ways for finding this value. The one, if function is homogeneous, we can use Euler's formula. If function is not homogeneous, we can use Euler's deduction formula. So the first thing we need to do, we have to check whether the function z, which is the combination of u and b, is homogeneous or not. So let us try to check. Firstly, I am just trying to check for u. It is given that u equals to x square y square upon x square plus y square into log of y upon x, which can be written as what? Equals to x power 4 into y upon x whole square, because I am trying to write it into function of y upon x square common, 1 plus y upon x whole square into log of function of y upon x. This got cancelled two times, which is what? X square into, you can see this term is a function of xy, and also log y upon x is also a function of y, not xy, y upon x. These terms are what? Function of y upon x. That is, the whole term can be represented or written like function of y over x. Why I'm writing? Because all of the expression is having y upon x term. And this is what, if you remember, is standard notation of a homogeneous function. And this is what a homogeneous function of degree, yeah, what will be the degree? 2. Because the standard notation, if you remember, is what? X power n into function of y upon x. So here I am getting that u is a homogeneous function of degree 2. Now talking about v, v is given as cos inverse xy upon x square plus y square, which will equals to what? Cos inverse, taking x square common from the first term so that it can be written as function of y upon x square common from the denominator. So y upon x whole square. This got cancelled, which will equals to what? Cos inverse of y upon x upon 1 plus y upon x whole square. It means what? The whole function is function of y upon x, which can be written as function of y upon x. Is it in a standard form? Yeah. But x power n is not there here. Is not there now. So what should I do? X power 0 into function of y upon x. Now you can see it is reduced into the homogeneous function. So I should write it is a homogeneous function of degree 0. It means, students, u and b are the homogeneous function but having the different degree. If suppose that they are having same degree, it means z is also a homogeneous function of degree same as u and v. But here the degree is same, not same. One, u is having degree 2 and v is having degree 0. And what the question is asking? They are asking x into del z over del x plus y into del z over del y. And what they say? The value of z? They are saying the value of z is x plus u plus b. Remember, here we cannot apply n times z. Why? Because z is not a homogeneous function. individual components of Z are homogeneous of different degree, but Z is not homogeneous. So I'm just reducing it in terms of U and V. So let us see what will happen. Do the multiplication. So x into del u upon del x plus x into del v over del x. Just do the multiplication. Same over here. Plus y into del u over del y plus y into del v over del. Now just combine the term u on one place and v on one place. So this will be x into del u over del x plus y into del u over del y. The same for the terms of b, x into del v over del x plus y into del v over del y. Now you can see this is the result of Euler formula, and u is also a homogeneous function of degree how much? 2. This will be 2 times u. And this is for V. V is a homogeneous of degree 0. So 0 times V. So finally what I get? 2U is the answer for this problem. I hope you understood the concept. What I did here, Z is not given directly. It is given as the combination of two functions U and V. I just check them individually, whether they are homogeneous or not. If they both of them are homogeneous of same degree, then in that case what should I do? It will be direct n times Z, but here Z is not homogeneous, so I just convert it in terms of u and b and apply the result of homogeneous Euler function for Euler's theorem and get the required result. Hope you understood the concept.